Hello! So this year's pre-release program for AQA A-level computer science is a program called Symbol Puzzle. And in this video, we're going to look at the pre-release material alongside the code and the text files. So before we start, I'll give you 1 second to quickly subscribe to the channel. Alright, I assume you've done it. So let's start. Now, Symbol Puzzle is a single-player game where the user needs to place symbols into the grid, building up patterns. The user can place the letter Q, T, or X as the symbol, and those are placed into the empty cells on your grid, attempting to make a larger pattern of those letters. So you can see here in figure 1, there's a Q formed from multiple Qs, then there's a T formed from multiple T's, and then there's an X formed from multiple X's. Now these patterns are formed on your 3x3 section on the grid, and those are 9 cells altogether, as you can see. So each time the user places a new symbol in the grid, the puzzle compares the cell in the grid looking for pattern matches, and the objective of the program is to get the highest possible score by adding valid patterns into the grid. The puzzle can either be played using an 8x8 standard grid, which you can see here, or by loading a 5x5 external file, which is a partially complete puzzle. So you see your text files, puzzle 1, puzzle 2, puzzle 3, and puzzle 4. Those can be loaded to get a 5x5 grid rather than an 8x8 grid. Now each valid matched pattern awards the user 10 points. So if you can get this pattern, this pattern, this pattern, you would get 10 points each time, and those scores would be added as long as you can get the correct patterns. The puzzle, however, has fixed number of symbols available, which is 38 for a standard puzzle, and a different amount depending on the external file that the user decides to load. Once a valid match for a specific symbol has been identified, the cells in that 3x3 sections are modified so that the same symbol cannot be placed into any of the cells in that 3x3 section of the grid in any of your future moves. So this prevents overlapping patterns of the same symbol type being placed into the grid. However, your symbols of different types can be placed into those cells, allowing your patterns to be overlapped if a different symbol is used. So what I mean here is, if you have formed this pattern shown in figure 1, you're not allowed to place any more Qs in this 3x3 section. So even if that's using these empty cells, you're not allowed to place any Q. However, you can place some T's, you can place some X's, but you're not allowed to place Q. Same thing with T and X. As long as you've made a pattern for that specific letter, you can't override it with another letter which is the same. Now you would realize on your grid you've got some blocked cells as well, which are represented by your @ symbol. Now the user cannot place a symbol into these cells, and when the user has exhausted all their symbols, the puzzle is complete. So once they've attempted 38 different letters, that's the end. Now let's look at the program overall. So we've got 4 object classes in the program, and that makes this program relatively straightforward in comparison to all the previous year's pre-releases. So what you can see on the screen is a UML diagram, and if you're not fully familiar with a UML diagram, I'll quickly whiz through it. So basically at the top here, we've got the class name, then the next section tells you the attribute names, and then lastly we've got the method names. So this section is your attributes, this section is your methods, and the top is the class name. So the first one we've got is a puzzle class, which represents the puzzle in the program. It contains the attribute and methods which can manage the puzzle, such as the score, the grid size, the allowed patterns, and the different available symbols. Next up, we have got our pattern class, which is representing a pattern that can be matched within the puzzle grid. So it has a symbol and a sequence of symbols forming the pattern. Now next up, we've got the cells class. So the cell class is the parent class or the superclass to our blocked cell class. We'll look at that in depth in our next video. But basically this class represents each cell within the puzzle grid and contains a symbol and a list of symbols that are not allowed in that cell. Lastly, the inherited class, blocked cell, is being inherited from the cell, and this represents the cells that cannot be changed, or in other words, the cells that are marked with an @ symbol. So all of these classes work together to create and manage our puzzle However, there's no direct inheritance or composition between our puzzle, pattern, or cell class. However, there's an inheritance between the blocked cell and the cell class. Right, so now looking at the code, this section of the code defines the main function, which serves as the entry point to the program. So this prompts the user to enter either a standard puzzle or to load a puzzle from the file. It then creates a puzzle object based on the user input and calls the attempt puzzle method, which is basically to play the puzzle. Now, after finishing the puzzle, it displays the score and prompt the user if they want to play another game. So this is kind of like the menu for our puzzle. Looking at the next section of the code, so this is our puzzle class. The init method initializes the puzzle object, and if it receives one argument, it loads the puzzle from a file specified by the argument. So whatever was specified by the user is going to load up that. Otherwise, it's going to generate a random puzzle. It initializes attributes such as your score, symbols left, grid size, grid layout, allowed patterns, and the allowed symbols. Next up, we've got the method in the puzzle class, which is our load puzzle. So this is responsible for loading puzzle data from a file. Now it attempts to open the specified file, reads the data, and then initializes puzzle attributes based on the data that's being read. If an error occurs during loading, it's going to print a message indicating that the puzzle could not be loaded. Next up, we have got our method inside the puzzle class, which is attempt puzzle. So this is responsible for allowing the user to attempt the puzzle. It enters a loop where the user can continue playing symbols into the grid until there are no symbols left. So within the loop, it displays the current state of the puzzle grid, gets the user to enter a row, a column, and the symbol placement. It then updates the puzzle grid according to what was entered by the user. Once the user has placed the symbols, it returns a final score. Next up, we've got the cells class. Now this is responsible for representing individual cells in the puzzle grid. It initializes attributes for the symbol in the cell and then lists of symbols which are not allowed in the cell. So you might be wondering why I'm talking about the list here, but basically when we look at the code in depth, you would realize all the grid cells that you can see, whatever goes inside those are stored as a list. So the data type that's used is a list. It also contains methods for getting and setting the symbol, checking if the symbol is allowed, adding symbols to the list of not allowed symbols, and then updating the cell accordingly. So next we have got the blocked cell class, which is being inherited from the cells class. It represents the cell in the grid that are blocked and that cannot contain any symbols. So it initializes the symbol as an @ sign and then overrides check symbol allowed method to always return false, indicating that the symbols are not allowed in the blocked cell. So this one's essentially responsible for making sure wherever you see the @ symbol, the user can't enter something. If name equals main, now this section checks if the code is being run as the main program, and if so, it calls the main function to start the puzzle game. Now one thing to consider and one thing to clearly remember is how the pre-release material has mentioned that there are errors in the implementation of the puzzle in skeleton code, which means that it does not work in the way described in this pre-release material under all circumstances. So if you can spot any error, try and work your way backwards to guess what question might come up in your exam in order to resolve whatever problem you have identified. Alright, so that's the end of our quick overview of the pre-release material. In the next video, we are going to go over each line of code in detail, and then we'll look at the content of the 4 different text files. I hope it helped. Feel free to email me any specific questions you may have, and I'll be very happy to help you out.